Καλωσορίζουμε στο βήμα τον κύριο Mozzarelli Fausto, του ανεξάρτητου φορέα πιστοποίησης CSI, Certification and Testing. Welcome.
Thank you. Okay. Hello, everybody. Thank you so much for having me here today. It's a great pleasure and an honor to be here. And I would like to thank Unistil for inviting me, all of you for participation. The translation team for the great job they have done, and they have allowed me to catch up with all the very nice presentation we had up to now. And what I'm here for is to share, let's say, our experience, the CSI experience in the safety field. CSI, just a few words about our company. We are a testing and certification body involved in road safety, not only for the roadside standpoint, but also in the automotive development standpoint. In fact, we are one of the 7 Euro NCAP laboratory that rates and support the development of new contents for safety in passenger cars. So this means that we have also a particular, let's say, feeling and let's say experience in regard of what are the current and future trend for passive safety. And I believe that this is important to say because more and more we will see in our safety design in road safety more involvement of new technology that goes behind the passive safety itself. We will see more and more connectivity between vehicle and infrastructure. We will see more and more interface between the design of road hardware and automotive, which is still lacking now. So, and again, I want to say that I'm very glad to be here, and I want to, and I'm very open to bring not only today, but even in the future, our experience, big or small that is, to your let's say table. Okay. What I will present today is some let's say application of the European standard EN 1317, which we are involved in terms of development, being expert in the CEN TC 226 work. And an application for sure, because in the, let's say, in the past years, we have been involved in some hundreds of projects for road safety hardware and certification as a test house and a certification body. Just a brief overlook of on the standard itself. So we are talking, I will talk about the EN 1317 standard, which is a technical standard that is meant to, let's say, evaluate the performance of safety hardware, okay? This is actually not all we need to bring a product into the project, because definitely we also need, beside a good standard for evaluation of the performance, we need also national law in order to properly, let's say, apply the project to the need of the local infrastructure, okay? So what the standard does itself, just to avoid any type of misunderstanding, the standard, EN 1317, is one of the most important set of standards for road safety we have all over the world. Sets the parameter, the target performance for a road safety hardware in terms of vehicle containment, in terms of, let's say, requirement for vehicle redirection, setting the parameter that evaluate with the sort of mathematical model the injury on the occupant of the car, and sets also the requirement in order to ensure that the road safety hardware does not constitute an hazard in case of an impact against it. Okay, but this is a standard. So what does that mean? Means that the type of tests that we run are not 100% equivalent to what is going to happen on the road, okay? So means we have the feeling that what we are testing is statistically relevant, but is not always the case of what happened in a real crash. So this needs to be kept very clear in mind, because at the end of the day, we need to perform tests and also apply the standard in order to make sure that what we are testing is as much as close as possible to the real application, okay? So when we speak about EN 1317, we are speaking about a set of standards which is quite diversified. You see there is a core part of the norms which is related to the general terminology and general criteria, which is part 1. But then you have part 2, 3, 4, up to 8 that deals with different road hardware. Not all of them, not all of these standards are so-called harmonized. So it means not all of them deals with a CE certificate at the end. Okay, currently the only two that we for which we can grant a CE certificate are part 2 for side barrier and part 3 for crash cushion. Okay, while there are still a lot of road hardware that are not covered by CE certification, even if the standard is present, and we are keep working in order to define and improve the standard to have a good assessment way. But these products, such as the transition, terminals, motorcycle protection system, and so on, are still let's say, under the umbrella of national homologation. So it's going to be the national authority that keeps the reference standard, for example, EN 1317, to release its own homologation. Okay? So if we go, but this is very important, again, saying that we, in a test laboratory, can assess the product, but not always assess the real crash scenario, which is totally, let's say, a different part of the road safety engineering. Okay, when we deal with the testing, we basically take measurement out of the execution of a testing method. That means making sure that we have a repeatable and reproducible way of assessing such parameter. Okay. So what are the type of vehicle and type of scenario that we deal with? According to the classes of the barrier we need to evaluate, we deal with different type of vehicle. Always a road or side barrier needs to be tested with two type of crashes. One is a TB11 with the 900 kilogram car, that is meant to evaluate mainly the severity indices. So what could be the injury in case of an impact for the occupant of the cars fitting in the car compartment. Okay. Then in respect to the level of containment of the barrier, you have a second test which is meant to evaluate the capability of the barrier to redirect the vehicle, okay, to contain the vehicle. So it's the, let's say, a so-called high energy impact, okay, that can be done with another type of car, heavier and with more energy, let's say, in case of N2, and it goes up passing from trucks, buses, and articulated truck up to the H4 classes with H4B classes with the 38 tons truck. Okay, these are pretty much the type of vehicle that are involved. The first one is always be present in the test, while the other are differentially used for the different classes of vehicle. Again, it's really important to tell you that the standard we are using is not yet perfect. And so you can imagine that there is quite a big variety of vehicle that can be employed in our testing standard, and this somehow may affect the result of the test itself. Nowadays, we believe that we have a good compromise between, let's say, the cost efficiency of this test and the reliability and repeatability and reproducibility of the measurement that we provide. But there is definitely still room for improvement. This is the reason why we keep working in our CEN committee. And what I've just said doesn't deal only with the vehicle selection itself, but also in the way of preparing the vehicle. You can imagine in a test like the last one we see here, the TB81, when you have about 20 tons of ballast provided on the vehicle. Also, the way you secure the ballast to the vehicle may affect both the stiffness and the stiffness of the structure itself, and the vehicle dynamic, and eventually may also have some slight effect on the performance of the barrier itself. These are type of influences and parameters that we are more and more addressing also with the help of additional tools such as the numerical simulation. So we are getting more and more confidence and knowledge about the effect of the different parameters. Okay? So as I said before, every barrier is then tested with at least two type of impact in regard to the class it belongs to. When we were saying before, very briefly, what are the let's say parameter severity indices that we collect with the car that relates to the injury of the occupant value, we need to precise that we are not fitting into the car any anthropometric test device sensor as we do in other type of testing, for example, for vehicle crash testing. Here we have a much more, let's say, essential numerical model that simplifies the occupant as a numerical model and evaluate the kinematics of this ideal occupant by the means of the acceleration and angular velocity read at the center of gravity of the vehicle. Just to say that this is one of the well-known approximation and assumption that we have while we evaluate this AZI, which is an acceleration parameter, and the THIV, which is the theoretical head impact velocity, which is again the theoretical velocity at which this theoretical model head impacts the inner part of the body of the vehicle. So nothing has to do with the real capability of a vehicle itself to restrain the body and to mitigate the forces coming into the human being body. But we believe that for such type of application, this is still the best way of having an indicator that allows products to be compared one to the other without exceeding with the complexity. So nowadays, this is the best option we have. Okay? We will see in the future what will happen, but nowadays, this is really important to point out. And again, when we run a crash test, beside this type of parameter, we also need to assess the proper behavior of the barrier itself while it's interacting with the vehicle. Means it should safely redirect the vehicle, should not brake, should not protrude the vehicle during the redirection. Clearly, we also have numerical parameter to evaluate on the barrier that deals, you all well know, that deals with the, let's say, geometrical deformation, dynamic deformation of the vehicle, of the barrier, and to the maximum display, which are working with and dynamic deflection. And you also have parameter that deals with the maximum, let's say, displacement of the vehicle while it's working on the barrier in order to select the proper point where install the barrier respect to the obstacle that may be present around. How we run the test. This is just a quick look of how we do the test in CSI. We have built a remote control system that allows us very flexibly to remotely drive any type of vehicle. We have different impact area, so we can impact the barrier. Oops, wow. Excuse me. I was trying to use this. We have many impact area. One is here, one is here, one is here, where we can install 110 meter of barrier in order to test safety barrier. We can test terminals over here. We can test crash cushion in different type of foundation, means soil, asphalt, concrete. And with this type of, let's say, procedure, since we are not pulling the vehicle, but we are driving the vehicle wherever we like, we are very flexible in running testing on different type of condition, different impact point as well on the same system without making, let's say, new installation. And this also allow us to make also research activity, changing quite flexibly the direction, the impact point. So we test side barrier in different type of foundation, as I said. And as I said, we need to try to, let's say, test in the closest way to the future installation scope of the system itself. In this case, you see a TB11 test on a bridge parapet, which is installed on a deck. So what we have here is a concrete beam, which is installed in a female foundation. Let's say these are precast concrete elements that we can switch in order to simulate the different type of curbs that the barrier may have, on which the barrier may be installed. So we are very flexible in, let's say, changing according to the design specification of the project, the different type of curb, which may be very relevant in the final result of the system. Because if you test the barrier on flat and then you install it on a curb, you may have big, significant difference. So this is one of the parameters that definitely needs to be evaluated. As you can see here, we also simulate the free space behind the deck in order to make sure that there is a proper interaction between the vehicle and the bridge deck, and the vehicle is free to see the void after the barrier in case of large deformation, let's say. While this is another type of application, a soil installation for an N2 system. As you can see, this is a typical way of behaving of a barrier with post and rail disconnection. Very smooth redirection of the vehicle into the road. If you have enough working width available, this is very, let's say, forgiving system. When you run testing on this type of a system, again, in regard to the foundation, you need to be very careful about the way you provide the soil characteristics to the barrier, because we will point it out a little bit later, but it's very relevant that the crash laboratory provides to the manufacturer a set of information related to the stiffness of the foundation where the barrier was tested. Because what we do is to assess the product, providing parameter, but this parameter depends on the foundation where the system was tested. So if you take the same system and you install it on and was tested, let's say, on a hard soil, and you then install it on a vegetable soil, the performance may be dramatically different. So it's very relevant then when the manufacturer gets to the real road and working on a project, provides information about the performance related to the proper, let's say, condition where this parameter were measured, okay, in order to make sure that you can have a similar condition on your project itself. Okay, excuse me. So I just wanted to show you a similar test with the bus. Now, as we said before, not always the tests are successful, so this is clearly what the barrier should not do in terms of containment. And the last example I have related to the side barrier testing is an H4B type of testing, with which is the maximum level of energy we test in according to EN 1317. Actually, as an exercise, 3 years ago we made a so-called H5 type of test, which was with a 44 tons vehicle at 75 kilometers per hour. We ran it in CSI because it was quite easy to do it with this technology. And so the first feeling we had is that the type of a system, even stiff system that we currently have for H4, are not still, let's say, sufficient to keep this type of energy. But this is going to be maybe a future requirement. It's still under evaluation, let's say. But the need came from the fact that on certain European road now the trucks become more and more heavy. So 38 tons sometimes is not enough to be representative of what we have on the road. Again, just a quick overview of what happened for crash cushion. Everybody knows what crash cushion are, which are they have a big difference with respect to the side barrier because they are meant to absorb energy instead of simply, let's say, instead of mainly redirecting the vehicle into the road. So absorbing energy in order to protect obstacles such as piles, poles, pavement tool, okay? As we were saying before, the matrix of tests, they are mainly designed to let's say, provide their work in regard to the impact collision with cars, not with the heavy vehicle. And when you test them, you need to test them according to a, let's say, quite complex scenario of impact. So you have head-on impact full overlap, such as scenario 1. This is the system itself. This is the obstacle it protects. Then you test them according to frontal impact with offset, frontal impact centered with an angle, side impact for those that needs to be redirective, and also back impact. The back impact mainly is meant to evaluate that in case of upcoming traffic from the opposite side, the crash cushion do not constitute an obstacle. Okay. Again, even here we have similar parameter to evaluate the behavior of the system that do not need to constitute an hazard, needs to have a proper foundation according to design specification. And again, you also evaluate parameter related to the severity indexes on the occupant, on the occupant of the vehicle. So we were saying absorbing energy. This is what I meant for absorbing energy. The vehicle is stopped. And in this way, the system provides a crash-worthy, let's say, force on the vehicle. So you need to have space in order to mitigate the deceleration and in order to stop the vehicle while, let's say, saving life of the occupant of the car and protecting the obstacle that lies behind of the crash cushion itself. And as we said, they work for protecting crashes frontal, but they also supposed to redirect the car in case of lateral impact. So, provided that this is what we do in terms of testing, let's say very briefly, let's say what comes next in terms of certification process. In terms of certification process, in regard to side barrier and crash cushion, as we said before, we can currently provide, since we have harmonized standard, we can provide CE certification to the product, and we can provide it because we have been notified by one of the ministry of the European Union. Okay, so this means that the job we do in terms of notified body is to run the factory production control and audits to the manufacturer in order to make sure that they have a quality system in place and they produce the system with the sufficient level of quality, and they are capable to keep the performance of the system while they are producing it. Okay. the type of performance they need to ensure are the performance that are shown during the crash test, the initial type testing report, which are definitely correlated with the material analysis, that is the qualification of the material employed into the product that needs to be, that are very relevant, that needs to be kept along the complete life and production cycle of the system. Then what we also do, and I would like to point out, is we evaluate modification of the system, because one thing is the initial type testing and the initial certification of a product, but in real life what very often happens is that the product needs to be adapted, needs to be submitted to some change. So we will see later how we assess this type of change, because EN 1317 tells us that. So we basically evaluate three categories of modification for the product, which are A, B, and C modification. And according to the level of modification, we may have, we need to have different assessment of the impact of this modification on the product performance. Because what is really important to keep in mind when we evaluate a product modification, the main goal is to prove that the constancy of the performance. Because if the performance change in terms of working with dynamic deflection, biomechanical index, this becomes another product, okay? So when we evaluate a product modification, our task is to make sure that the performance are kept constant, okay? So we can evaluate three types of modification in order to have different type of assessment. For type A modification, which is a very simple modification, we will have simply let's say a description of the modification, because after we run a risk assessment of the modification, we evaluate the modification is so, let's say, has so small impact that does not require a deep dive on the evaluation. While if you have type B modification, you will need to have a partial testing, or it is also allowed in EN 1317 to run evaluation with numerical assessment, only for type B modification. And it has to be done very carefully, because the numerical simulation need to be treated with only if we can, if the designer can prove that the model is very well correlated, and the notified body can treat it only if he has the competence to evaluate the numerical simulation. And in EN 1317, we specify how to provide a proof of a proper correlation of a numerical model. And this applies for only to type B modification. So when the modification is considered after a risk assessment to be significantly relevant but not crucial for the change of the performance of the product. Because in case the modification is considered to be at a high level of relevancy, becomes a type C modification, and a full vehicle crash test is mandatory at that time. Okay? So again, about the numerical simulation that we can use only to evaluate the constancy of the performance in case of type B modification, for nothing else in EN 1317, we need to make sure that the model is the numerical model provides meaningful data, okay? So the model needs to be validated, and in the working group we have in CEN TC226, we have a specific working group that deals with the numerical analysis, and they have provided a continuously improving, but currently I would say a good set of specification and methodology to evaluate the accuracy of the numerical model. So in EN 1317 Part 5, it is currently defined how to assess a numerical model. Okay? So very basically, when you assess the modification of a product, you have the crash test for that product. So first step is that the numerical simulation needs to be capable to reproduce the same result that the crash tests have shown. Okay, and from that moment on, you can work with that model to evaluate the modification itself. Okay, and currently because let's say again the technology we have with the finite element method now is quite accurate, but the phenomenon we are evaluate are highly nonlinear, dynamic. It may have a specific behavior of the system, so they need to be very carefully evaluated. So the type of modification, so the numerical simulation is also very helpful for evaluating the modification, or also running assessment in terms of parameter change. Okay, so as soon as the modification has been proved to keep the constancy of the performance, the new modified product can be included in the family of products that have been granted with the CE certificate. Okay, let me just I will be very brief with the last topic I have for today, which deals with installation, because again, we apply EN1317 as a standard to evaluate the performance, but as I said before, we need to be, we and all of you, I mean, the road designer, the barrier manufacturer, the authority, the ministry, needs to be very careful that the system has been tested in such a condition that needs to be relevant respect to what you install on the road. Okay, so let's take a look of what happened for the installation of a barrier on soil, and what may be the main differences you may have respect to the crash test. So basically we can say that the main difference you may have from a barrier installed on the proving ground and on the road are the distance of the installation from the edge of a ditch, in case the ditch is present, and the soil characteristics in terms of compaction. Okay? How do we assess the compaction of the soil? This has been a very longly treated argument, and I believe that now we came up with let's say, a reasonable conclusion. First of all, I have to tell you that until, let's say, a few years ago, we have been, let's say, defining the soil characteristics in a way that is very much similar to what the road designer does. And this doesn't pay off very much when you have to assess the behavior of a beam which is bending, dynamically bending in a volume of soil. So we have to, let's say, conceive a new way of assessing the performance of the soil. So means not only evaluating the stiffness, the compaction, but also running dynamic testing, push-pull testing on the post itself. Okay? Let me just show you what I mean for that. So this is the type of testing I'm talking about. So we have a specific hammer that knocks the post, loads the post during his real installation, and you can even test a very rigid bar, such as HEB, very stiff post, such this one, in order to compare with the same post the stiffness of the different soil, but you can also test the specific post of your barrier in the same soil in order to evaluate how that post behave in that soil. But generally speaking, if you want to evaluate how stiff is your soil without considering the behavior of your specific post, such type of a test with a high stiff post is the best solution. We have been working a lot in the definition of such type of a testing. We have been running and comparing dynamic testing and static testing in order to find the best compromise, in order to be very efficient in running the test, in order to have tests that can be run on the road, because you have the result of a crash laboratory, but then how do you assess the soil in your installation field? So you need to have machines similar to the one I've shown before, which can be moved, can go to the proving field, to the installation field, and test the soil. And this is very relevant before you install any type of barrier. what we have proven is that it's engineeringly reasonable to run such type of a test also with the static loading, because it is enough to compare the stiffness and to respect to the initial type testing. So it's not strictly necessary to run such type of a test with a dynamic, let's say, type of loading. When you get to the dynamic type of loading, you have several complications. So you need to provide a cushion between the hammer and the post, because you need to filter several dynamic behavior that may happen. You need to be much more careful in keeping the let's say, torsional and bending buckling of the post, because we are working with open section that fail for torsional buckling when you load it in bending. So this is to say that the push-pull test is the king method to evaluate the soil characteristics, and it can be done either statically or dynamically. Just for your, let's say, curiosity, where we were evaluating the proper method for testing the soil, we have been, let's say, keeping confidence with the soil behavior and soil reaction, and we have, for example, discovered for certain type of, let's say, dimension of the soil gravel, how the stiffness of the soil changes when the concentration of the gravel increases. So, for example, you can see that the more the gravel is present into the soil, up to 50%, you can have in the push-pull force time history or force displacement plot, which increases in value, in magnitude, but then it drops when you go to the 70%, which is more than 50. So at certain stage, the stiffness drops because you have, for this type of dimension of the gravel, you have too many void in the soil that comes to reduce the stiffness of the volume itself, respect to the push-pull test. Okay, so there are again different also model to simulate the soil behavior, which is quite complex, that has been recently introduced. There are some which are numerically more efficient, such as one-dimensional model, such nonlinear spring that keeps all the parameters such as moisture, depth of the position, and so on. Or you have also more complicated three-dimensional model that deals with the behavior of the soil considered as a solid or as a fluid. So this is simply to say that also the level of knowledge respect to the numerical modeling of the soil today is quite high, and we can provide quite good correlation of the push-pull test itself. So just two slides to the end. So what we are going to introduce in the new EN 1317 standard, I'm talking about the draft because for, let's say, political reason was not yet finalized and voted. But what we expect after the job we have done to be included in the next approved standard is the definition of a push-pull test that first of all defines the constitution of the soil itself. So there are going to be defined 4 types of foundation: standard soil, fine soil, special soil, or paved soil that needs to be defined for that specific initial type test. The soil in the proving ground needs to be prepared in a standardized fashion. In fact, we prescribe that the soil is compacted with layer of 30 centimeter as soon as you have defined the, let's say, constitution of the soil itself. And then this is simply to, let's say, provide what is the characteristics in terms of mixture of the different type of soil. And then you need to run a push-pull test. You need to run a push-pull test with a stiff beam, as I said before, and to acquire the time history of force versus displacement. With this type of plot, you have the best characterization of the stiffness of your foundation. You have, together with that, you have the parameter that defines the barrier behavior, and then you can go to the installation asking for the similar soil to install the system in order to ensure that you will have the similar result that you have been acquiring during the ITT. Talking about soil, I just would like to show you, and I believe it was shown before, but this is a very interesting result that Unisteel have obtained addressing such type of issues related to the proper installation. They have conceived a new design of a barrier, which I would say is a sort of cutting-edge technology that allow a proper behavior of the system even when it works at the very edge of the ditch. Oh, I'm sorry, but I can see it here, but you can't. Let me see if I can show it to you. Okay, so, but anyway, this is it was relevant in this soil installation evaluation because it's very clear explanation of what a manufacturer should do, let's say. Thank you very much.